Um, Hi, everyone. Thanks for joining my talk. I know there were a bit of technical difficulties, and this is the last talk before lunch, which sucks. I'm sorry. But as a presenter, I think it's the best because I don't expect any questions in the end, and we could just go eat. So my talk is called Motion and React. And a little bit about me before. I used to be a front-end engineer at Eventbrite. Was actually on the same team with Ben, who you've heard from yesterday about the nifty tips to perform better performance for your React code. While I was there, I've also been lucky enough to become a core contributor on the Yarn package manager. But currently, I'm a UI tools and operations engineer at Netflix. It's been quite a change for me. So I've joined the company for about 2 months. And working on tools 100% of the time is exciting because I've always been passionate about developer experience and tooling. But I thought I would feel like this every day just working on the cutting edge stuff. But in reality, it's a little bit more like this because there's a lot of battles to be fought on multiple fronts, right? Like CI, CD, automation, and testing. And what's really exciting about working in the JavaScript community is that there are new things coming up all the time. And that's a challenge as well as the most rewarding part of it. So it might be a little interesting that I'm giving a talk on motion because tools and motion design seem pretty far apart. In fact, CSS often makes me feel like this. And when I'm learning CSS, I only have one book that I could use, which I also happen to use for the rest of my development learnings. So then I kind of get into this existential crisis of, am I a UI engineer or am I a tools engineer? But I think that all becomes a moot point because it all comes down to caring about our end users and usability. A good dev tool provides abstraction without hindering knowledge and intuitive and timely feedback, as well as ability to be portable and integrate with the existing ecosystem of tools that you're currently using. Similarly, a good motion design provides usability through affordance, and content and accessibility. And it's especially critical in areas like mobile design where you have limited real estate. It's also a feedback mechanism between the product and the user. And you want to build something that conforms to the existing user behavior rather than against it so that it gives a native and natural feel to the user. So that seems pretty relatable to me, and I'm ready to make some tweens. But then it's 2018, right? Like front-end development, there are so many ways to build something or one tiny thing, and the internet will give you hundreds of options to do it. And it often makes me feel like this. And this is apt because this also describes my learning style, which is maybe with a bottle of wine, but really bottom up. Because if you think about it, animation is a pretty low-level thing, right? How you move the pixels across your screen depends a lot on your environment and language, as well as the frameworks and the library you choose to use even before you get to your code. So I'm going to break this into 2 parts. First part talking about the environment, which determines your rendering engine, languages, and capabilities. We're most familiar with the web, right? But React has taken over a lot of different platforms as well. And even within the web, we have engines like WebKit or Gecko. Depending on which platform you're using, you have to ask yourself questions like, what is the DOM equivalent? And do you have access to the new features of JavaScript and CSS, if any? And do you have things like request animation frame? Do you have OpenGL available? These are all the questions that you should be asking. One example of this is our TV UI team on Netflix is built on top of JavaScript compiler, which doesn't have HTML and CSS. So the easiest analogy I could think of is probably like Electron or React TV, built specifically for talking to different device APIs of TVs. So because of this, our our animations all have to be done in JavaScript. And your environment not only determines how you should be building motion, but also what you should be building as well. The way you convey information differentiates or it depends on what kind of environment you're in. So on the left side, we have the famous swiping gesture of Tinder, which feels very sleek. But on the right side, they launched an ad for Tinder for Desktop, I believe last year, and it's quite not the same, even though visually they look the same, right? First of all, I don't know who has the courage to swipe on desktop. And second of all, I don't know who has a computer that old enough, from the 90s, I think. But if you look aside that, from that fact, then dragging is different from swiping, even though visually they look pretty similar. So it's important to keep that in mind, but for now, let's focus on the web because that's where we have CSS and Friends, and that's what we're most familiar with. The most basic and easiest tool to use out of the box is CSS transition, which is great because it gives you a declarative API. You have transition states using pseudo selectors. You could do something more complex like timing, easing, and duration, and you could combine it with other CSS features like media queries. And because CSS feels very native to the browser, you get performance and compatibility out of the box. On top of that, you have CSS animation, which gives you all the benefits of CSS transition, but you get the keyframe API. So this means you could do additional things like infinite loops instead of just going from point A to point B. It's also important to note that when you're using CSS properties to animate, not all properties are created equal. If you think of each of this JavaScript as having a runtime where a frame is executed consisting of these 5 steps, from compiling your, from running your JavaScript to laying out where the elements will go on the page to filling out the actual pixels and ordering the elements, the gold standard is 60 frames per second. That means each of this frame has to take under 16 milliseconds. And you want to optimize for triggering processes that happen in the later stage of this frame because they happen in a waterfall fashion. And to do that, you want to use properties that are cheaper to manipulate, like opacity and transform, versus things that are not so cheap to manipulate, like width, height, position, or padding and margin, which trigger what's known as layout or reflow. And you can see a complete list of this on csstriggers.com. So overall, CSS seems pretty great, and it's probably true. You could probably solve like 80% of your use case. And you might ask yourself, when do I actually need JS? JS really shines when you have complex interactions across user behavior, multiple components, and data sources. CSS transitions and animations are fire and forget, meaning once it's fired, you have no way to hook into it or stop it even. So if you take an example like the loading state in Twitter when you open your app, it's pretty self-contained, right? It doesn't need to know about anything else going on the page. Versus an interaction like this, as you scroll down, your profile image switching depends on the user scroll behavior. And something like this, purists might argue, requires a separation of concern between presentation and behavior. Presentation being focused in the CSS part, and behavior really being left for JavaScript to control. So we know that JavaScript is equipped to do these two things because A, it has state management that allows it to coordinate across between different components and sources. And B, it has the event loop, which allows us to hook into the user behavior and all of the different browser events. There are a lot of examples in real life. Notification bar that toggles between success and fail states. Maybe you have complex data visualizations. Maybe you want to do something snappy like page turning, snap to grid, drag and drop, or you want to explore even more complex things like game development and storytelling. But overall, one of the strongest suits of JavaScript is that it it's closer to the browser, and it gives us a hook into the rendering process, which is what's known as, which is enabled by what's known as request animation frame. So again, we go back to this frame, right? If we think of the browser as having a life cycle of many frames, something like set timeout has no idea where in the process it gets executed. For visual learners, set timeout is like Kanye. But request animation frame, on the other hand, doesn't take interval as an argument because it doesn't rely on timing. Instead, it relies on browser's implementation. So you'll notice that previously you would have done something hacky, like you call set timeout with 1,000 divided by 60 to achieve that 60 frames per second, but it's not always guaranteed to be called in the same place in the next frame before layout, and that could cause what's known as layout thrashing or jank. Versus request animation frame just gives that work to the browser, and then the browser will always make sure that it gets called at the same time, and browser might also do something smarter, like if you're on an inactive tab, it'll slow down your animations, and Chrome is known to do that. So one thing that JavaScript, again, gives us is this ability to know about all the different internals of how the browser works, right? So we're experimenting with in-depth transition at Netflix, and we need JavaScript not only because that's our only option for TV, but because we don't actually know what images we'll be getting back. That is based on your recommendations that Netflix returns for you. And we also want to prioritize some images, right? Like the billboard image versus the box images by controlling the distance. And we could also hook into other capabilities of our engine, like 3D rendering, which this is doing. Aside from all the capabilities, JavaScript's real strength is also in the community, right? The community has solved a lot of the problems that CSS community hasn't yet. And that's related to modularity and portability and testability through amazing open source projects like Jest. And you also have the polyfilling and Babel ecosystem, which allows you to use features before they even come out in the browsers. So like, we're all JavaScript developers, right? We feel good about doing things better than CSS. Well, that's also not true, because there might be a merging that's happening, hopefully not quite as violent as this one. But we're moving to a place where the separation of concerns is not about between languages, but by components, right? And React has instilled this behavior in us. And we have seen this with efforts like CSS and JS, right? So right now, if you were to use style components, you could use keyframes with it and animate accordingly. But there are also more exciting things coming, especially in the native browser. So one is the Web Animations API, where it gives a first-class citizen status to animations. So that means you could attach methods like animate on your element, as well as methods like pause and play. Another one that I'm really excited about is called Houdini, where it's a cross-browser effort to really provide JavaScript with the building blocks to manipulate and interact with CSS. And some of them are already in production in Chrome. One that's really nifty that you could use right now is called the CSS typed object model. Previously, when you were setting values, like a numerical value to a CSS property like opacity, when you actually get it back to read it, you'd get back a string, which was weird because I set it to a number, and then you'd have to do all these parsing and stripping and recalculating to pass it the next value. What the typed object model provides is this property called attribute style map, which gives you a specific setter and getter guaranteed to give you the same type back, so that when you do calculations again, like in the request animation frame call, then you can basically get this optimized interoperable property back. And you also have helper methods like, does this node have a specific property? You can call delete on it and clear on it as well. And it also gives you a hook into the Paint API, as well as ability to set CSS custom properties. So just more ways for you to write CSS in JavaScript. And at this point, it doesn't really even matter what, like the line is blurred a little bit here, right? So it's handing you over the full control to control the rendering of your elements. Just much like how Babel or the polyfilling allows you to work with the features that aren't available yet. And you could try this out yourself. All you need to do is go to Chrome flags and then turn on experimental web platform features. And yeah, and this project is, I believe, in active development, and we should see a lot of exciting progress made here. So that was a bit about the environment. So the second part I want to talk about is the framework, which determines the libraries and code you should use because it determines your programming paradigm and priorities. In React, we care about two things, right? Functional reactive programming, as well as composition and abstraction. Notice that animation isn't part of this, right? React isn't opinionated about how you write your animation. For that, we have awesome third-party libraries that already have solved this problem. You probably have heard of GSAP or Anime.js, Popmotion, 3JS, and so much more that the community has come up with. I specifically went with Popmotion because I think it plays nicely with the React functional paradigm, right? So what you do is you pass it the ref, and you basically let the third-party library hijack the DOM by getting the getting the ref and then animating it. And Popmotion has this declarative API again, so that you just tell it what you want, and it'll do the thing. So this is great, but it's not that great that we have to pass it the ref, right? Because that means it requires DOM access, and we don't have access to lifecycle methods. I mean, granted, we get the performance, browser compatibility, and the community-tested benefits. So what do we want next? Which is, like, let's use React for what it's good for, right? Which is the composition and abstraction part. And that part is, again, solved by the community. React Transition Group used to ship as part of the React add-ons, but now is completely a third-party package. And it provides three main APIs, the first one being a transition, which provides you a low-level API for hooking into components, mount and unmount states. And it does so by artificially setting state between entering and exited, so that you don't have to so that you don't lose the element when you unmount. For React, it's been like pretty difficult to do an exiting transition. So this solves a problem by providing its children components sort of this artificial state, because React doesn't have something like should component unmount, right? It's not opinionated about how you animate these things. It just passes this transition state prop. One level up from that is the CSS transition, which actually uses the on-entering hook of transition to add and remove classes, and it does so by causing reflow. All you do is provide it a class name, and you could either do this via JavaScript or CSS, but it'll basically handle, apply the transitions that you specify to it. And then you have transition group, which isn't about really how it's animated, but about orchestrating between different transition components. So you could also use what's a library known as React Motion, which is slightly more powerful than React Transition Group. In CSS, you really have 2 points of control, which is time and distance, right? But in the JavaScript scripting world, you have basically access to any algorithm you want, and that includes Spring Motion. So the idea of this library is that you allow physics rather than timing to determine movement. So you'll notice that you don't specify duration when you're using React Motion. Instead, each subsequent call to the children components will get its previous style. The end effect of using Spring Motion versus a linear motion is that you get this lifelike quality. And this is a technique that's actually used in animation films as well. And all you do as an end user of this library is to provide a configuration object consisting of stiffness and damping. Cool, but what if I want everything, right? I want CSS and JS, functional programming, and React components. Give me the world, and React will give it to you. My favorite pattern to do this so far has been using styled components with React Pose. So React Pose is a library written by the same guys who wrote Popmotion. So you'll see that it's wrapped in a styled component, but all you do is provide this configuration object. So again, we don't care about duration or timing. Just like React Motion, we let the property that you configure figure out whether it should use a tween or spring motion. And all you do is provide it a prop called pose that lets you toggle between these different states, whether it's full screen or thumbnail mode. And I love the simple API of it. And I think it works well in the long run. But the TLDR of this talk is that, A, you want the motion to be part of your design spec, right? The way we're moving towards using GraphQL on the client or React Suspense, we have this gap time between waiting for data fetching to occur, which means loading state and animation will play a bigger role. And B is you want to have a framework for introducing frameworks, right? We could have the entire world, or we could have something very minimal that just relies on CSS. The difference is that you have to weigh the pros and cons of performance or more control or composition and reusability with things like build process, bundle size, or developer overhead. So thanks. That's it.
Well,
I think we're good.
Well, if you have any questions, I mean,
you could find me after.
We can still, or you can catch up with KAYLIE later, maybe, in a hurry.